to introduce you now to another key ClinEpiDB feature, which is data visualization using Analysis app. And Danica in her introduction showed you how some of these work, but we are going to review this again in the next 15 minutes. So all this morning, we have spent time looking at variables within a study and exploring the distribution of single variables. The next step that is of great interest in epidemiology is to start exploring the relationship between two or more different variables. ClinEpiDB features 3 apps which allow you to perform interactive data visualizations right on our website and explore relationships between variables to generate hypotheses. And these are the Distributions app, the Contingency Tables app, and the Data Summaries app. Before we begin, I must emphasize that these apps are intended for data exploration only, and they should not be a substitute for more rigorous analysis. But they are a great starting point for coming up with interesting questions to ask of the data. I'm going to give you a demo of the analysis and visualization apps using one of the data sets called the SCORE S-Mansoni cluster randomized trial. This study focused on a neglected tropical disease called schistosomiasis. And this disease is caused by the parasite that you see here, the schistosome. And the study was conducted in 3 countries in sub-Saharan Africa, in Cote d'Ivoire, Kenya, and Tanzania. The intervention here was a drug called praziquantel, which was delivered via mass drug administration, or MDA, meaning large groups of people were treated at a time. And this was a cluster randomized trial where villages were assigned to different MDA regimens. The SCORE program conducted operational research, meaning they asked practical questions which would inform policies and programs. And here they were asking a question about what is the best way to deliver MDA. You have a finite supply of the drug. How can you use it most effectively? Specifically, they were asking if MDA should be given every year, or can you give it, say, every alternate year and still get the benefits? And also, what is the venue of MDA? What is the ideal venue of MDA? Should you deliver it to the entire community, or can you deliver it to schools, which is much easier to do and still get the same benefits? The SCORE program did this study in high prevalence areas in Kenya and Tanzania, where the goal was to gain control of schistosomiasis, which was very high. And they also did similar studies in moderate prevalence areas in Kenya and Cote d'Ivoire for sustaining control of the disease and making sure that it does not get worse. The idea was to randomize villages within the study area to different venues and timings of MDA regimens, and then to compare them. The target population was 9 to 12-year-old children because this is a high-risk age group for this disease. And they tracked the study villages over 4 years. So let's now go and do a live demo of this study. When I click on this study, it brings me to the dataset page, and I can go to the search wizard, which will allow us to explore the data right here. And you can see that this was a large study. It had almost 250,000 participants over the study. Over here, you can see some of the study details, such as the study arm. There were 6 study arms. And the study type. Like I said, there were 2 types of studies in either high or moderate prevalence areas, called the gaining and the sustaining studies. In the geographic region, you can see the countries where the study was done. You can see that almost 50%, exactly 50% of the villages were in Kenya. And in the participant tab, we can see basic demographic information such as the sex of the participants and the age group. Those can be found here. And in the sample tab, we can see the samples that were collected on these participants. Stool samples were collected and processed to detect schistosomes and also soil-transmitted helminths like hookworm, ascaris, and trichuris. For the schistosome, you can see that there are 2 types of variables. There's one variable, a binary one, which simply tells us whether the participant was positive or negative for schisto. And there's another variable that tells us the actual egg count of the participant. So let's go ahead and choose a subset of this data to analyze. I'm going to go back to study details, and we can see there are 6 study arms. Here, S stands for school-based, C stands for community-based, and the SSSS tells you that school-based treatment was given every year, and if there's an H in the code here, it shows you that it was a drug holiday or a year in which drug was not given. So for our analysis this morning, I'm going to choose arm 1, which was an arm that got either 4 years of school-based or 4 years of community-wide treatment with no drug holidays. So they got drug every year. Let's go over to the, and you can see the minute I did that, we filtered our participants, and the number of participants has reduced. Next, I'm going to go and choose all the participants that were in Kenya. And so we can look at only participants in Kenya. I will go over to the participants and choose the 9 to 12-year-olds, since they were the target population of the study. And if at any point you forget what you filtered on, just click the green filter icon and see. We were doing arm 1, MDA each year in Kenya, and 9 to 12-year-olds. Now we have about 20,000 participants selected. Let's go over and look at them. So I selected, I went to the participant list, and this here, the blue analyze results, is where you will see the 3 analysis apps. So this one will give you distributions, which is histograms. Here you can run contingency tables. And in this app, you can run data summaries, that is box plots. So let's go and do a contingency table, make a contingency table. The question we are asking is, did MDA even work? Let's look at the study from beginning to end and see what MDA did to schistoprevalence in the participants that we studied. So here I'm going to go ahead and look at schistoinfection. And I'm going to say any schisto positive. That's what I'm going to choose here, the binary variable. And this can take a few seconds because the app needs to talk to the database. So just hang in there. And you can see on the other side here, I'm going to leave it as it is because we will look at schistoprevalence in our selected population. Okay, let's go back. This at least once is fine. And I'm going to say positive, that schisto was positive at least once. So here we've chosen schistopositive. Here we've chosen our selected participants, which were 9 to 12-year-olds from Kenya in either high or moderate schisto areas. And here I'm going to go ahead and stratify it by time point, so that we can see how the proportion of schistopositive participants changes over time. I can go over here and if this is taking too long, I have a search already made, but I think this is okay.
As this is coming up, let me just comment briefly, Nupur, about the time frame required to run some of these analyses and some of the other functionality that you may observe. So you may observe, for example, that in trying to find a variable, when you type in Shigella or Mansonai or whatever you're looking for, that it may take some time for it to actually find that variable. Or if you're looking to revise a search that you run previously, that may take longer than you'd ideally like. The reason for this is that all of these queries are being run in the background dynamically. None of this is pre-computed, as is clearly the case for these Shiny apps that Nupur is running. So particularly if you work in an environment with a low bandwidth setting, that may require you to wait for a minute or two rather than a second or two, which we would like to see. But do have some patience. And if things don't come back for you, or if you are confused, or it takes an unacceptably long period of time, please click on the Contact Us link that you can see up at the top of the page and let us know so that we can work to address those issues so that this is not a limiting factor for anyone wherever they're working in the world.
So here, exactly. And it really only takes a minute or two to come up. And here what we've done is we've set up all our parameters. That being schistopositive, we've selected our participants, and I've said study time point, show us the whole study time point, and show us by whether the study was done in a moderate or high area. Over on the left-hand side, you can see that you will be able to see summary statistics on the parameters that you have run. You will be able to see contingency tables, and you will be able to see the actual plot grid. It's a good idea if you're working with a small number of participants to look at the contingency tables to make sure that you haven't stratified and you have too few participants in any of your strata. But what you see now here is a plot grid, and let's break it down. So the blue portion of the bars is showing us the proportion of positive schisto cases, and the green is the negative ones. And you can see how the proportions change over time. The upper row is the gaining study, which was the high prevalence villages in Kenya, and the bottom row is the sustaining study, or the moderate prevalence villages in Kenya. And the first bar you can see are selected and non-selected. So in each pair of bars, the first bar is the selected study population. So when we are looking at the graph right now, let's focus on the selected population, or the first of every pair of bars. So what are these graphs showing us? In the high prevalence villages, the schisto prevalence started. So let's look at the top row. The schisto prevalence started at, look right over here, where you see the proportion, 65.5%. So that was the proportion that we started at baseline. Over the years, this proportion went down to 58%, and then to 47%, and then to 38%, and finally at 34% by the end of the study. So the schisto prevalence went down by about half in these participants over the course of the study, which means, yes, MDA is working. What happens in the bottom row, or the sustaining study? So here you have, of course, this was, remember, the moderate prevalence. So you see the prevalence is much, the blue is very much lower in the lower row compared to the upper row. But here you started at about 18% and then went down to 8% right away, and sort of stayed there over the course of the study and ended at about 7%. So overall, what this is showing us is that MDA brings down prevalence, but there is a plateau effect. It doesn't go down to nothing. And the conclusion of this can be that you will need other interventions other than the drug and the MDA to bring down the prevalence further. And this was exactly one of the conclusions from the publications that came out of this trial. So we have demonstrated how in a few minutes you're able to visualize this data and get to one of the conclusions of this large study. So this was a demonstration of some of the interactive features of ClinEpiDB. And I think we are ready to take a 15-minute break now, and then it will be your turn to try using the visualization apps and doing a complex search, because we have a couple of exercises for you in the next breakout session. Thanks.
Before, do we want to make the breakout session longer or still at the same time?
We can make the break 15 minutes, Sam, and then come back and make the breakout session longer, because there are 2 large exercises next.
Okie dokie.